Good morning, friends. Today we are going to study about the programming styles or programming paradigm. So far we have covered that Java is a object-oriented programming language. But are you aware about what other programming paradigms or programming styles available except object-oriented programming? So let's see some of them. Okay guys, so here are the types of programming styles. I have included 5-6 programming styles. You can see that there are also more of them. I have included those that are widely used. So let's begin. Let's study them, firstly in a summary, and then we'll go through the detail of each of them. So first one is imperative. So imperative means control flow is an explicit sequence of command, which means it allows the control flow using a sequence of commands. Then is declarative, which means program state the result you want, not how to get it. So it states that the result you want, it won't, define how you will get it. Then is structured. So in structured programs have clean, go-to free nested control structures. So it's like a clean programming, everything you know, you're having nested control structures that are braces within a braces. Okay. Then we have procedural. Procedural means it means imperative programming with procedure calls. So it also include sequence of command, but it allows procedural calls. Okay. Then is a functional programming, which means computation proceeds by nested functional calls that avoid any global state. So it allows functional calls in a nested block. So you can say it's a mixture of a structured and procedural where it allows a structured nested control structure, also the function calling. So it does avoid any global state. So everything is defined in a function. Okay, and then it's object oriented. Now you must be aware what is object oriented. So it is basically computation is affected by sending messages to objects. Objects have state and behavior. Okay, so this was a one-liner introduction of each of them. So let's study some of them in detail. Okay, so first one we are going to study is the imperative programming. So in imperative programming, control flow is imperative programming is explicit. So, the control flow is explicit. You have to explicitly define, this is going to execute in a way like statement 5, statement 6, statement 7. And then in case you want after statement 7, it should go to statement 11. Then you can use a go to statement or something like that. So, like for example, machine language, it is an imperative, it uses imperative programming. And yeah, the each step affects the global state of computation. So let's see an example where this code example is not a machine language programming. It is just a programming example that is created just to show how imperative programming is implemented. So you can see it starts from some declaration of something as result, and then and then there is a start statement, and then it followed by number of statements, and there's like next statement. Then just to call start again, we are using go to start. So just don't go by the syntax. You know, it could be possible that it is a syntax of some other programming language, but it is used here just to show you how imperative programming is implemented. So it does contain some sequence of statement and how the sequence should be followed. It is telling us using statements like next, go to, and so on. Okay. Some of the advantages of imperative programming, that is efficient, it is close to machine. Well, it was popular and it was familiar. Okay, and the disadvantage includes the semantics of program can be very complex to understand and prove. So, to write those syntax, to understand it could become complex. The reason is because it is close to machine language. It's always difficult for human to understand the machine language. Side effects also make debugging harder. Abstraction is more limited than with some paradigms. Order is crucial. That means sequence is crucial, which does not always suit itself to the program. So it could be like, you're making your program very, very complex, by including so many go to and so many next statement because you have to keep in mind that um, the sequence should be like really followed. So it does make your program really, really complex sometimes. So nowadays it's hardly used, but yeah, initially when the programming languages just was launched or just started to came, so this was a programming paradigm that was followed. Okay, next is a declarative programming. So in declarative programming, the control flow in declarative programming is implicit. Imperative programming, it's stated that the control flow is explicit. That means you need to explicitly define it. But over here it's implicit. You don't need to explicitly define like where to go next. Okay. The programmer states only what the result should look like, not how to obtain it. So it does not contain any loops or assignment, etc. Whatever engine that interprets this code is just supposed to get the desired information and can use whatever approach it wants. So some of the examples that uses declarative programming are Prolog, the database query languages such as SQL. So while declarative principle also supports programming or a procedural style of programming. So when we talk about SQL, so it's a mix of declarative as well as a procedural style of programming. We'll study procedural style in like a slide to come. Okay, so this is an example of declarative programming. So again, like it's just to show how declarative programming is implemented. So it is just having, I think we are using a SQL example over here, which is a mix of declarative and procedure. That's why, you're seeing that it is using a select statement. Then there's a like a method kind of a call, which is upper, which is a predefined method in SQL, and then it is applying that select statement on a table that is known as people. So just don't go into the syntax. You don't need to learn the syntax. It's okay if you're not able to understand these syntax. It is just to show as an example how it is implemented. It's absolutely fine if you're not getting the syntax. Okay, then moving forward to structured programming. Structured programming is a kind of a imperative programming where control flow is defined by nested loops, conditional subroutines rather than via goto. So we don't have goto in structured programming, rather we have loops, condition, if else blocks, subroutines. So that's how we define control flow. So it does allow the flow of sequence of statement using loops and condition. So, the early languages that emphasize on structured programming was Algol 60, PLI, Algol 68, Pascal, C, Ada 83, Modula 2. Now you must be seeing that I'm using C in a structured programming. Well, I would like to tell you that C is a multi-programming or a multi-paradigm programming language, that it does contain some feature of structured programming. It does contain some feature of procedural programming also. So it's not purely structured, but yeah, it is. You can consider it in a part of a structured programming. Okay, so let's see the example. So this example to me looks like somewhat C code in which we are defining I don't know, a result, and then there's a loop used. So again, it is showing you how the structured programming is implemented. We are using a loop, a for loop. Well, it's not exactly C, but yeah, whatever language it is using a for loop. And then it is also using a control structure if statement. And then it is also returning and calling a method. So, all these features are included in a structured programming language. Moving ahead to a procedural programming. So as I told you, like C is a mix of structured and procedural. So yeah, we also include C in a procedural programming. So all these languages in procedural programming, they describe step by step exactly the procedure that should, according to a particular programmer, be at least be followed to solve a problem. So it defines everything in a form of a procedure, like step by step execution in a form of a procedure. Okay, so the examples are C, Basic, COBOL, and Fortran. So, it allows step-by-step execution and it allows procedural call. Okay, moving forward to functional programming. In functional programming, control flow is expressed by combining functional calls rather than by assigning values to the variable. So in functional programming, we define everything inside a function. So the real power of this paradigm is you can call a function from within another function. So this is just an example. We are calling a sort method, and in the sort function, we are calling another function filter, and this filter function again includes another call to a function called map. So that's the power of functional programming. With functional programming, there are no commands, only side effect free expression. Code is much shorter, less error prone, and much easier to prove correct. There is more inherent parallelism, so good compilers can produce faster code. Example is Haskell. So basically, Haskell is a pure functional programming language. Other example like C++, Object Pascal are purely procedural or purely object oriented, or they can contain elements of combination of programming paradigms. So I will state that languages like C and C++ are multi paradigm programming languages, so they support features of multiple programming paradigms. Finally, the object-oriented programming language. So the object-oriented programming language were created such as Simula, Smalltalk, C++, C Sharp, Affile, and Java. In these languages, data and methods to manipulate it are kept as a one unit called object. Okay, so basically it's kept as a one unit called as a prototype, which is class, and for that class we create objects. So the actual unit which we can use is called object, and the prototype how that object will be created, but all object will have is shown by class. The only other way the object can use or access our data is via objects method. So two objects can interact with each other by calling each other's method. Thus, the inner working of an object may be changed without affecting any code that uses a object. So, object-oriented programming language also include features like inheritance, polymorphism, encapsulation, data hiding. We'll study all of that in detail in later tutorials. So, the Java, the language that we are studying in this tutorial, is a object-oriented programming language. Okay, so this is an example which says that there is a class A and it is having some variable. Then it is also having some method like void met1, which can contain some code. So this is how the object-oriented programming languages are implemented. So this code is very close to the Java programming language. Okay, guys, so thank you for now. I hope you enjoyed it and this tutorial was helpful. So we'll meet in the next tutorial.